Chapter 7, Section 3, Problem number 1. Calculate the following probability. Probability of A given F. So let's look at our formula. A given F is the probability of A and F over the probability of F. Again, remember this symbol means the and. So the probability of A and F, so A and F is the 0.02. So 0.02 over the probability of F is 0.20. So 0.02 divided by 0.20 is equal to 0.10. So the next one, the probability of D given E is the probability of D and E over the probability of E. So the probability of D and E is 0.35. This is D and E. 0.35 over the probability of E, which is 0.80. So 0.35 divided by 0.80 is 0.4375. And the next one, the probability of E given B is the probability of E and B over the probability of B. So E and B is equal to 0.10. So 0.10 over the probability of B. B is 0.18. So 0.10 divided by 0.18 is equal to 0.556. Now let's look at problem number 2. Here you have applied for 2 scholarships, Scholarship M and Scholarship A. The probability that you receive an athletic scholarship, which is Scholarship A, is 0.25. The probability of receiving both is 0.10. Probability of getting at least one is 0.3. Again, remember the at least means one or the other. So what is the probability that you will be receiving the merit scholarship? So here you have your formula of M or A is equal to the probability of the merit, which is M plus the probability of A minus probability of both, M and A. So plugging in our problems, our 0.3 is the A or M is equal to probability of M, and we found the probability of M to be our unknown, plus the probability of A. Probability of A was 0.25, and minus the both, which is 0.10. So doing a little algebra here, you do the 0.25 minus the 0.10 and then subtract it from the other side. And we found our unknown to be equal to 0.15. Next problem, what is the probability of receiving an athletic scholarship given that you have been awarded the merit scholarship? So now you want to find the probability of A given M. So now your formula is the probability of A and M over the probability of M. So A and M, we know it to be 0.10 from the problem, over the probability of M, and we just calculated the probability of M to be 0.15. So 0.10 divided by 0.15 is 0.667. And the next problem, what is the probability of receiving a merit scholarship given that you have been awarded an athletic scholarship? So what is the probability that is merit given that you have been awarded athletic? So it's the probability of M and A over the probability of A. So the probability of M and A, we know both to be 0.10 over the probability of A, and the probability of A was 0.25. So 0.10 divided by 0.25 is equal to 0.40. Going On to problem number 3. Here you have a table in a study to determine the frequency and dependency of left-handedness relative to females and males. So now you want to find the probability that the person chosen at random is left-handed. So the probability that the person is left-handed. So looking at the total left-handed here, you have 130. So 130 over the total of 1,000, and that is equal to 0.130. The next one, what is the probability that the person chosen at random is a left-handed woman? So the probability that he is left-handed and female. So left-handed and female, so we go to the and, which is in the table. So you have 52 over 1,000, and that is equal to 0.052. The next one, what is the probability that the person is a female or a woman given that the person is left-handed? So the probability that she is female given left-handed. And again, your formula is a probability of female and left-handed over the probability of left-handed. So here we have both female and left-handed. So female and left-handed, we got it to be 52 over 1,000, which is 0.052. And probability of left-handed, we got 130 over 1,000, which is 0.130. So 0.052 divided by 0.130 is 0.4. The next problem, what is the probability the person is left-handed given that a person is a male? So the probability that the person is left-handed given male. So here you have the probability of left-handed and male over the probability of male. So left-handed and male is 78 over 1,000, which is 0.78 over the probability of male. So total males is 560 over 1,000, which is 0.560. And doing that calculation, 0.078 divided by 0.560 is 0.139. And the last problem, number 4. An applicant has applied for positions in company A and B. The probability of getting an offer from company A is 0.4. Probability of getting an offer from company B is 0.3. Assuming that the two jobs are independent, what is the probability that the applicant gets an offer from both companies? Again, remember, probability of independent means probability of A and B means the probability of A times probability of B. So you multiply the two probabilities, which is equal to 0.430 times 0.30, and that is equal to 0.12. So A and B is 0.12. The last problem, the applicant will get an offer of at least one. Again, at least is one or the other. So we have a formula of A or B is the probability of A plus the probability of B minus the probability of both A and B. So here we have the probability of A or B is equal to the probability of A, 0.40, plus probability of B, 0.30, and minus the both, which we just calculated it, 0.12. So doing that math, you have probability of A or B is equal to 0.58. And that concludes Chapter 7, Section 3.